Oh, hi guys. So I'll be discussing this problem, make some divisible by p, which is a LeetCode daily problem, like today's LeetCode daily problem. And I see the acceptance rate is very low. So even I faced a lot of difficulty while solving this problem, but eventually I was able to solve this problem, and I can understand where people might have gone wrong and gave up. Um, so let me just try to explain like how I came up with a solution, because even I was trying to submit this and sometimes I was getting TLE because I was not using the modular arithmetic in a right way. So let's try to see this problem. So basically we need to uh, in this problem we need to find the smallest subarray. uh, after removing that subarray, the remaining sum should be divisible by p. Okay, so that was the question more or less. And we need to uh, you know so it's very easy to come up with prefix sum approach, because the prefix sum approach will uh, can be used to find the smallest, or any sub array with a given sum, right? So we can use the prefix sum approach definitely there. But how do we do that? uh, like let's say you know let me just go to the iPad screen. Okay, so let me just start fresh. So let's say you have an array like a1, a2, a3 till n, and let's say there was a prefix sum that you wanted to remove. And what would be the number, the sum that you would like to remove? That will be total sum mod p, isn't it? Because that will be your remainder. So this is the remainder that you want to remove. And we know that using prefix sum and hash map, you can find a number like exactly like two sum problem, right? So you could find another number whose sum, you know okay, I think in two sum we just wanted to find, okay, whatever it is, but just understand that if this is the prefix sum, and here let's say the prefix sum was p, right? And I want to find a subarray, subarray ending at I. So ending at I, which has a sum like x. So I'll look up in my hash map where is p minus x, so that if this was 10, this was 5. So if this was summing up till 5, I can remove this sum, right? This sum 5 from this whole 10, and I can get a subarray which has a sum 5, right? Similarly, I can do it for 6, 7, 8, 9, 10 as well, right? Whatever I want. And this is exactly what we wanted. This now, to find the minimum subarray, we can just tell our hash map to update every time to the rightmost index. So basically we can pre-process this, like, so first I can find my answer, and then for anything I can just update my map, that for p just update it with I, right? And I think this till now this seems easy, right? But the thing is, like, we need to find the remainder, right? But the problem is, like, if you go with, let me go back to this screen. Yeah, the problem is, like, if let's say the remainder is some number r, you can just imagine, right? And let's say I'm standing at an I whose prefix sum is like p. So I just check for p minus r. So if I remove this part, right, then of all these subarray, I can take the minimum out of it. But this will be one of those subarray that I can take out, right? So this is p minus r, and I remove that. But do you guys see that just removing r, is not gonna be sufficient, right? Because if let's say this p was big enough and we remove p minus r as well, and that will also divide. So let's say our map had p minus r. At this point, I need, if I just go and start checking for every p minus r also I check, then I check p minus r as well, right? That is not efficient, right? So that was the whole problem, I guess. That is where you need to come up with a modular arithmetic approach, or kind of modulo. So instead of saying, instead of storing the prefix sum value, the whole value, what we'll store is like the prefix sum till here modulo the number which we are given, which is p, right? By doing this, what can we say? Ki if let's say at this point the prefix sum modulo p is pi, okay? Now let me just give this another. So modulo pi is this value is modulo p mpi, okay? Now for this I should check the value, the rightmost value, which is like whatever this value is, mpi minus the remainder that we're trying to see, right? We can check this value modulo p. Now the thing is, here we need to think of one thing, that if you subtract, in modular arithmetic you need to do a plus as well, and then you need to take a mod, and this value is what you will look into your map to find the answer. And I think most of the people would not be able to think about this, and that's why the acceptance rate is very low, because this is little bit related to maths and arithmetics, modular arithmetics. I think people are the question has a very very low acceptance rate. But if you think it in terms of modulo, instead of storing the whole prefix sum, if you think it in terms of modulo, like every index I'm storing the remainder which it will give, the sum of the array till I modulo p. Basically it will tell me the remainder that is extra in order to divide p. And to find our answer, we can go to find another modular prefix which has this value. So I hope my cursor is visible. So this value, and that was the whole problem, I guess. Now I'll give you one more example which might seems more. So basically we can do a very small dry run or something. Before that, let me just write down the code for this. So even I was doing the same mistake. I was storing the prefix sum value, and I was trying to iterate over every remainder which could be possible for every I. So I did like 1,000 iteration, but it was failing, of course, right? They have such test cases. Otherwise, I would never been able to learn this, new way to use hash map and modular arithmetic to solve a new kind of problem, if those test cases were not there. Okay, cool. So we have, I hope my screen is visible. Yeah, it's visible. So we go like this. So let's do one thing. The thing is, you don't even need to store prefix sums. Yeah, you only need a map. But it's okay. Just for let me just call this prefix sum, or you can call this prefix mod p, or something like that. I think, okay, I don't like this name. Prefix mod p. Okay. And this should have prefix mod p of I should be prefix mod p of I minus 1 plus nums of I minus 1. So I have converted this into a 1 based indexing. Like my prefix at I will store in terms of 1 based anyways. I percentage equals mod. Why should I do mod? I should do. So I know my total sum should be equal to prefix mod p last index, right? Last index is now n, it's not n minus 1. That's how I have stored this. And remaining is total sum percentage p. If this remaining itself is 0, then you just return 0, because in this case we don't need to remove anything. Now here comes the map. And I can have map of 0 equals to 0, because there can be a situation where we need to remove a prefix itself, and yeah, that's why we need to have this count. And then I start from I is equal to 1, I less than equal to n, I plus plus. So I go to every prefix I, right? What is the thing that I need? Okay, I can write it like that, and that will be the prefix sum I here. So I can do prefix mod p I here minus remaining plus p. Now it's very important to understand why plus p, and not like just to make it in the range 0 to p minus 1. Yes. So I think I can do a dry run over that problem, but if I can do a dry run over one test case where it might be, make you clear. But okay, I think I have a better solution as well. So let's say if this was 2, our remaining was 4. Okay. Oh, come on, what this? Okay, let it be there. Okay, so let's say our remaining was 4, and right now I'm at 2. I'm talking about the mod prefix p. Okay, I'm at 2, right? So I'll look out for 2 minus 4, is it? Which is minus 2. Will my prefix ever store a negative value? All the values are positive in the array, so it will never. So we should not look out for minus 2. Instead, we should look out for, whenever we are trying to look out for, we should also look out for a mod p value. So if we look out for a mod p value, this is the mod p value, but we cannot do a negative mod, so we just add one more p here. Now in terms of problem, if you see, okay, so here some number would have been there who is giving us modular prefix p as 2, right? So let's say if p was 5, so this would have been something like 12, right? And we could search for 8, right? 12, so for 12 I should search for 8. Okay, so when you do 8 mod 5, you get 3. Okay, or how do I make you understand this? So for 12, yeah, if I remove this part, that is fine. So I do 2 minus 4 plus 5. So what is this value coming out to be? Modulo 5. This is coming out to be minus 2 plus 5, which is 3 mod 5, which is 3. So I'm looking for 3 here, right? I'm not looking for minus 2. I'm not looking for this. I should look out for a value which is in range of 0 to p minus 1, right? And I should look out for a value which is equal to this, because now my prefix array is storing all the mod p value. Okay, cool. I hope this should kind of clear it, but you can again do another dry runs to just understand about this problem. So this percent is p. Okay, so this is the value that I should look into my hash map. I'll update my hash map after everything with prefix mod p I equals to I. Okay, let's have an answer variable. It should be like 1e29, and then we can have answer is equal to minimum of answer comma mp of need minus I, right? Because this is what I'll be subtracting. This is one based indexing, by the way. I'll just do this. Okay, and it's not taken. Okay, cool. Okay, what is this? Redefinition. Okay, I think this should work. I think this was the error. Anyways, mp.find need should be, and this should not be +1, as so that's self-doubt. We can have something like that. This is fine. That should be I minus mp need. I think that should be I minus mp need only. Yes. Okay, let's run this. I'm still getting. Oh man. Okay, I was missing two things. First, I think by mistake there was a colon there, but that's how it is accepted. Okay, thank you guys.